Hello, today is day 6, Exponential Applications Practice. We've learned a lot of this, so we're going to get right into it. Let's start with number 1. Number 1 states, the money A, after T years, that the principal P will become if it is invested at a rate of R, compounded n times a year. So basically it was just saying everything we already know of the compound interest formula. So it says, to the nearest tenth, how long will it take $2,500, this is our initial value, to become 4,500. This is our ending value. And so we've got 4,500 equals 2,500 times 1 plus, it's invested at 0.07 or 0.7%, compounded quarterly, and it's asking how long, how many times it's compounded, and then to the t. So the first thing we have to do before anything else is divide the 2,500 over. So you're going to get 45 over 25. The zeros will cancel each other out, equals 1 plus 0.07 divided by 4 raised to the 4t. You'll notice that I'm not simplifying. The calculator can do it all. We know that this is what we're looking for, and so therefore we need to use logs. So we're going to take the logarithm of each side. And we know that with logs, this can come out in front. And so what we've got here is log of 45 over 25 equals 4t log of 1 plus 0.07 divided by 4. And now we're looking for what t is, and you'll notice that we can just divide by 4 log of 1 plus 0.07 divided by 4 to this side. To get what t is. And so you plug that in your calculator. Yes, you use alpha y equals enter, and you make sure that you do that. And when you do that, you get approximately 27 years. So you'll see that nothing actually changes here. Everything that we've done is what we do. So I would like you guys to try number 2, and if you don't have a calculator, I want you to get to what t would equal. Notice that you didn't need a calculator to get to this, so I would like you guys to try that. Even if you don't have a calculator, at least solve for t, and you can finish that in class. So try it right now. Before we go on to number 2, I do want to make sure that you realize that number 1 I was wrong on. It is 8.5 years if you use a calculator. What we should get is on number 2, we should get to be 27 years. And so here's the work as soon as the computer starts up. There's the work for number 2. Number 3, we're going to skip for right now. Let's go right to number 4. A new boat will decrease. Keyword there, decrease. And so we're decreasing at a rate of 8%. We know it costs $40,000 new. We're wanting to know the number of years it will take to get to the $18,000. So $18,000 equals, it was new, $40,000 times 1 minus 0.08 raised to the t. We're going to divide by the 40,000. So we get 18,000 over 40,000 equals, I'm going to reduce that to 0.92 t. Notice that the t is in the exponent, so we're going to log both, take the logarithm of both sides. And then, to get t by itself, you will divide by log of 0.92. To get an answer of approximately 9.6 years. Again, if any of this is, if you're struggling with any of this, pause it, go back to your old notes, and see. If we look at number 6 here, notice that it says if the meteorologist can determine how long a storm lasts, where d is the diameter of the storm, and t is the time in hours. If the storm lasts 4.75 hours, notice that that's time. So 4.75 equals 0.07 d raised to the 3. It says find its diameter. The key here is what? The fact that our exponent is not the variable. So please make sure of that. You do not use logs. 4.75 divided by 0.07. If we did that, then you have equals d to the 3 halves. What are you going to raise it to? The 2/3. So realize that. Please do not think it's just automatically logs. When you do not have the exponent raised to a variable, you do not use logs. Use the exponent rules. And d is then approximately 16.6 miles long. In the last one here, we're going to be talking about compounding continuously, which requires e. And so let's look at this. We've got the initial amount is 5,000. We have the rate, which is 0.07. Remember that you don't have the 1. You just have the rate. If it's decreasing, it would be negative 0.07 to the t, and that equals a. And so we're looking to determine the nearest dollar, the amount of money he will have after 3 years. So easy enough. A equals 5,000. E to the 0.07 times 3. And in your calculator, you will get right around $66,168.39. The question next is, how many years will it take to double? When we talked about this last time, we know that 10,000 is the amount that it's doubled versus from if it starts at 5,000. But remember that you can always, if it's doubling, just set it equal to 2. And now the question is, how do we get rid of e? And if we have forgotten that, it's the natural log. We'll take the natural log of both sides. We take the natural log of this. Remember that natural log and e are inverses of each other. And so you're going to get ln of 2 to equal 0.07t, and then divide by 0.07. And so t is approximately 9.9, which is close to 10 years. So again, nothing new with this, just reading the question and solving. And so I will see you in class to complete the rest of the notes. Bye.